welcome to this class. My name is Kirsten Mobani and I'm here to take you on the subject chemistry. Our theme for today is the chemical world, and we have a topic, the second part of this topic, particulate nature of matter. Atoms are very special to scientists because, as we said in our previous class, that they are the building blocks upon which molecules and other substances are formed. There were a lot of studies in the late 17th and early 18th century about the nature of the atom. A lot of scientists made a lot of assumptions about these atoms and how it behaves. One of such scientists is John Dalton, and the theory he put up concerning the atom is known as the Dalton's atomic theory. Now we'll be taking a look at two of Dalton's theories. First one says all elements are made up of small particles that are indivisible. These elements were called atoms. In other words, he said that atoms were the smallest indivisible particles. Second one says atoms of the same element are similar in all aspects and are different from atoms of other elements. We'll be seeing how some of these assumptions were modified later in our class. But first, we're going to take a look at what this atom is made of. Constituents of the atom. Now, in the early 20th century, scientists discovered that there were smaller particles that were present in the atom. So this goes to say that the atoms were really not the smallest particles. There were other particles present inside the atom, and they were discovered to be protons, neutrons, and electrons. It was discovered that the protons had a positive charge with a relative mass of 1. They discovered that the neutrons had no charge at all, but they had a relative mass of 1. They now discovered that the electrons had a charge that was negative and had a relative mass that was so small that it was almost insignificant at 0.00543. Here is an image of a typical atom. Now, the protons and neutrons were discovered to be located in the middle of the atom, known as the nucleus. The protons and the neutrons were discovered to be located in this nucleus, and this nucleus was discovered to be positively charged because of the positive charge of the proton in it. Remember that the neutron has no charge. Then they discovered that the electrons were located outside the nucleus of the atom. Also, some points to note is that atoms are made up of a positively charged nucleus. And as we said earlier, this is because of the presence of the positively charged protons inside the nucleus. The electron is a negatively charged particle that spins around the nucleus. So it means that the electrons were not located at specific points. They were constantly moving around the nucleus of the atom. Electrons are attracted to the nucleus by the positive charge of the protons. So this means that electrons were kept from falling out of the atom due to the positive charge of the protons. Now, there is a certain way that electrons are arranged around the nucleus of the atom. You cannot find electrons scattered. They have a definite arrangement in the nucleus. So, electrons are arranged in different shells around the nucleus. Let us take a look at this image. Here is an image of an atom. And this represents the nucleus of the atom, which is positively charged. Now, immediately after this nucleus are rings around it known as what? Shells. Now, the shell closest to the nucleus of the atom is known as the K shell. That is the first shell. Immediately after this shell is another shell known as the L shell, and that is the second shell. The third shell is called the M shell, while the fourth shell is called the N shell. Now, these shells have a certain amount of electrons that each of them can hold at a time. The shell closest to the nucleus, that we call the K shell, can only take 2 electrons. It is only 2 electrons that can fill it up at a time. When an atom has more than 2 electrons, then the remaining electrons will go on to fill the second shell of the atom. Here we have different shells and the maximum number of electrons that they can fill. The first shell has a maximum of 2 electrons that you can take. The shell next to it has a maximum of 8. The third one has a maximum of 18, while the fourth one has a maximum of 32 electrons that it can take. Now, electrons occupy the first energy level or innermost shells first. Now, this means that electrons will first occupy the shell that is closest to the nucleus. That shell closest to the nucleus is the shell with the least energy. So, electrons will occupy this shell first before they will go ahead to occupy other shells. So, it means that you cannot see an atom with electrons in the second or third shell and the first shell being empty. So they have to start first from the shells with the least energy and then move on to the next shell, and then they keep filling until they are finished. This diagram here represents the energy levels of the atom. We have the first shell, which we call the first energy level. The shell next to it is the second energy level. The third one is the third energy level. And so we see that this is how electrons are arranged around the nucleus. When electrons absorb enough energy, they can jump to another orbit of higher energy or shell. This tells us that even though an electron will have to occupy the first shells or first energy levels, these electrons, when they absorb certain amount of energy, they can jump to another shell with a higher energy level. In fact, electrons can keep jumping from one energy level to another, depending on the amount of energy they can absorb. Modification of Dalton's first atomic theory. Remember that we considered some of Dalton's theory, and now the first one said that all elements are made up of small, indivisible particles that are called atoms. This assumption has been proven wrong by the discovery of smaller particles, which were protons, neutrons, and electrons. So atoms were no longer the smallest indivisible particles. The next one that said that atoms of the same elements are similar in all aspects and are different from atoms of other elements. This assumption also has been proven wrong because some atoms of the same element were discovered to possess some differences in the number of neutrons that they possess. And this difference was what was referred to as isotopy. We'll be treating isotopy in our next class. Now, Let us quickly take a look at all we have learned. We say that atoms are made up of subparticles called protons, neutrons, and electrons. The protons and the neutrons are located in the nucleus of the atom, while the electron revolve round the nucleus in orbits. We say that electrons are arranged in different shells around the nucleus. Now we'll take a quick test. Which of the following subatomic particles has no charge? A. Proton. B. Electron. C. Neutron. If your answer was A or B, then you're wrong. The correct answer is neutron. Remember we said that protons have a positive charge and electrons have a negative charge, but the neutron has no charge at all. Dash are arranged in circular orbits around the nucleus. A. Electrons. B. Neutrons. C. Protons. A is our correct answer. Remember we said that neutrons and protons are located in the nucleus of the atom, while the electrons revolved around the nucleus of the atom. We have come to the end of this part. See you in part 3.